Hello students. Today in our lecture we will discuss about several other things in torsion chapter. Let us first of all discuss about the moment resistance of a hollow shaft. In the last class we have discussed about the moment resistance of a solid shaft. Now suppose the shaft is hollow. Suppose this is a cross section of a hollow shaft which is having the internal diameter of d2 and external diameter of d1. So suppose this is d1 and this diameter is d2, right? So what will be the moment of resistance for this particular case? uh, like the previous one, we will assume another element, uh, elemental area about x distance apart, which will be having thickness of dx. So suppose this is x distance apart from the center and the thickness of this elemental area is dx. Now similarly we will get the value of uh, torsional resistance. uh, if you take this elemental area and if you find out the torsional resistance for this particular area, then you have to sum it up. You have to integrate, but in this case the integration will be the higher limit of d2 and the lower limit will not be 0. The lower limit will be d2, the higher limit will be d1 and the lower limit will be d2. So the tr torsional resistance, like the previous one, this will be equals to tau r, where tau is the maximum shear stress at the surface of the shaft. R is uh, the radius, outside radius r, and we can sum it up, the elemental area dA multiplied by the distance square. But in this case the limitation will be you have to vary your x from d2 to d1, right? The lower limit will be d2 and the upper limit will be d1. So if you vary, then you will be getting the total tr for the section. Now similarly the value j we have got at the last class. The value of j uh, we got at as integration of dA into x square. But in this case, similarly in this case, the where the dA value was equals to 2 pi x into dx, right? Like the previous one. But in this case the limitation also will be from r2 to r1, where we are assuming r1 is nothing but r and r2 is the radius of the inner section, right? So this is r1, this is r2, so we have to vary our x from r1 to from r2 to r1, right? So if you vary, you will be getting the value of j, where j is what? J is the polar moment of inertia. So we will be getting the polar moment of inertia like this, right? Now if you find out this value, this will be equals to integration of 2 pi dx into x square, d 2 pi x 2 pi x dx into x square, right? This is the area dA into x square. The limits are r2 and r1, right? Now you the 2 and pi is constant, so this will be equals to 2 pi x cube dx, right? like the previous one. Now if you integrate, you will be getting the value is equals to 2 pi x to the power 4 by 4. The limit of the value of x you have to put r2 and r1, right? Now if you put those two limits, two values of x, you will be getting 2 pi r1 to the power 4 by 4 minus r2 to the power 4 by 4, right? If you take common this 4, and if you replace the radius with the diameter, then you will be getting 2 pi by 4. If you put the value of diameter, that is d1 to the power 4, and you will be getting 16. d2 to the power 4, you will be getting 16, as r1 equals to d1 by 2 and r2 equals to d2 by 2, right? So if you take common, you will be getting, so if you cut this 2, you will be getting pi by 2 multiplied by 16 d1 to the power 4 minus d2 to the power 4, right? So pi by 32 d1 to the power 4 d2 to the power 4. This is what, this is the value of J, the polar moment of inertia for a hollow shaft. Now what will be the polar modulus ZV? ZV is nothing but the polar moment of inertia divided by R. So pi by 32 d1 to the power 4 d2 to the power 4 multiplied by 2 divided by d1, right? So this value will be equals to pi by 16 d1 to the power 4 minus d2 to the power 4. This is the value of ZV, the polar modulus, right? Now what will be the moment of resistance then? Moment of resistance is nothing but tau multiplied by ZV, stress multiplied by the modulus of polar modulus, right? So if you multiply, you will be getting this equals to tau multiplied by pi 16 d1 to the power 4 minus d2 to the power 4, right? So this is our moment of resistance for a hollow section, right? Okay, now let us discuss about the torsional rigidity. Torsional rigidity is basically the torque required to produce a unit twist, that means twist of 1 radian per unit length, right? So for a unit length of shaft, if you want to get unit radian of twist, then the required torque is the torsional rigidity. Now what will be the value? We know the equation from the torsional equation. We know that was T by J equals to C theta by L, right? We know this. Now from this we can say TL by theta is equals to Cj, right? Now if L is unit, if theta is unit, then what is the torque? The torque is Cj, right? So we can say for unit twist, unit radian of twist, for a unit length of shaft, unit Cj amount of torque. So this is our torsional rigidity. Now let us see what will be the power transmission by a shaft, right? uh, the shaft is basically installed to transfer power from one end of the shaft to the other end of the shaft, right? That shaft has to transfer the power, right? Now that is why you need to first of all you need to know what will be the power transmitted by the shaft, right? Let us consider one shaft which is in working mode, which is having n number of rotation per minute, n number of revolution per minute, right? And n is the what? N is the rotation per minute, right? N is the rotation per minute, per minute. Suppose the unit is rpm, revolution per minute. And t is the average torque, right? And suppose this unit in is kilonewton meter, right? Then if this is the rotation per minute due to this torque applied, then what will be the work done by the shaft per minute? This will be equals to the average torque multiplied by the angle turned per minute, right? So what is the torque? T. And what is the angle turn? If number of revolution is n, then the angle turn for one rotation, the angle turn is 2 pi, right? So this will be 2 pi n, right? So this is the work done per minute. Now if you want to find out the work done per second, then this will be t multiplied by 2 pi n by 60, right? What will be the unit? This unit will be kilonewton meter. And we know that work done per second is nothing but the power, right? So we can say the power transmitted is equals to 2 pi nt by 60 in kilowatt, right? Kilowatt. This is in SI unit. Now if you consider MKS unit, in MKS unit, power transmitted P will be equals to 2 pi nt by 4500. This will be in horsepower, where this n will be in rpm, revolution per minute, and t, the torque, average torque, will be in kg meter, right? And this relation between horsepower and kilowatt is watt is 1 horsepower is equals to 746 watt, right? So this is the power transmission of a shaft. So there may be some examples that what will be the power transmission if the rotation and the torque is given. Maybe you have to find out another thing, you have to find out the rotation required. Whatever may be, you can follow these equations, right? And I suggest you to solve the examples in your home. Okay, thank you.